Great to see you here again in this new video about samples, sampling error and central limit theorem. In this video I will talk about the sample size and how the sample size influences the sampling error. But before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Now let's have a look at the sample size and the sampling error. When we have a population of big N, capital N, and we take a sample with size n, it means that we can calculate how many samples are possible using the combination formula. So we have the combination of small n to capital N is equal to capital N faculty divided by n faculty times n minus n faculty. And when we look at the previous example that we were discussing in the previous video, we had like 20 different possibilities. There are 77,520 different samples possible. So when we have all these samples, we have in fact a very large number of different possible samples and sample outcomes. Let's now have a look at some large and small samples. And we start from a small sample. When we take 3 elements out of the population, we see that when we look at the averages are still the same. The length is 1.70 m, age is 39, 54.9. You see the comma here is just from my Excel, which was using a decimal separator, comma as a decimal separator. But in your Excel, it may be a decimal point. Now, when we look at this, when we take only the 3 largest numbers, the length, the age, or the income, we find the maximum value of the sample averages. And we see for the length, it's 192.67 centimeters. For the age, is 60.67 years. And the income is $123.33 thousand or 1,000 euros. We also can find the minimum value when we have the 3 smallest numbers. We have 142, 24, and 25.33. And when we look at the sampling error, the maximum sampling error is given by the average, or maximum minus the average, and the minimum sampling error is given by the minimum minus the average. And we see that we have different errors here. For the length, it goes from 22.57 to minus 28.1, which gives us a delta, a difference of 50.67. And we can calculate that for all the 3 parameters. Let's now see what happens when we increase the sample size. And when we increase the sample size to 5, we see that the maximum value goes from 192.67 to 189.2. The minimum value increases from 142 to 146.8. And we see that the sample error, the sampling error, is reduced. When we look at the delta, the difference again, we see for the length that it went from 50.67 to 42.4. And we see the same tendency with the other samples, with the other parameters that we were measuring. So even going from a sample size 3 to 5, we see that we already have a significant change of the sampling error and the difference between the maximum and the minimum error. Now let's have a look to the last that I did, the last example I took here, where we have a sample size of 10. And when we look at the conclusions, you can stop the video and look at all the details. But we see that both values are getting closer to each other. So when we see that the difference between the maximum and the minimum sampling error is reduced, it's only 26.8. And when we look at the first one, n equal 3 with n equal 10, we see that that difference is about a factor 2. So it's very important to understand when we are doing samples, when we are taking samples and trying to find out what are the parameters of the population, we automatically find out, or we see, that the larger the sample size, the closer we come to the population parameters. Let's have a look at some conclusions. When we look at a table, a larger sample size leads to smaller differences with the population parameters. A larger sample size reduces the potential for the extreme sampling error, but you have to understand that due to probability, each sample has the same probability to be selected. So even with a larger sample size, it may result in a larger sample error anyway, because any sample can be any selection of all those numbers. So when we look at the extremes, we find the errors, the maximum and the minimum sampling error, but we also may see that when we make a random sample, those errors can be completely different because the numbers are taken randomly. We have to be careful about that, but we have to understand what are the maximum errors that we can expect. But basically, we don't know about the population. We don't know the maximum value of the population. We don't know the minimum value of the population. But sampling gives us an idea, and we know that when the sample size is larger, we are getting closer to the population parameters. That's all I wanted to talk about in this short video. Anyway, before stopping the video, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.